everybody. This is Data Science Sydney meetup at HERVE. Is that just me, or did anyone else here just race by? Glad to see many fresh faces here today. Many people I have not seen before, but again I didn't make it to my own meetup for a little. May I see who's new, who hasn't been to Data Science Sydney before? Yeah, okay. Welcome. My name is Fabian Held. I'm co-founder and organizer of this meetup. And when I'm not doing this, I'm a researcher, data scientist at Sydney Uni studying collaborative networks. Now, the purpose of this meetup is to create a community of enthusiasts who want to work in data science, who want to bring data science here in Sydney forward so that we can jointly here learn from each other, support each other, work together, and advance data science in Sydney, in Australia, from here. Some of you might know it already, there are a few sibling meetups to this one. There's a Sydney user of our forum, HERVE, that you might be interested in. There's health analytics and other streams of Data Science Sydney as well. They're not quite as big as this one. So there's DSS visualizations as well as an upcoming DSS strategy meetup as well. They will be announced, the last two will be announced through our meetup website. So just subscribe there and you will be up to date. So, next I would like to thank all the people. Without their support, this meetup wouldn't be possible at all. First of all, our hosts here at CBA, Perry Stevenson and Kevin Simone. Kevin, are you... Kevin at the back? He's the man to talk to about studying a career at CBA. So you'll be around, here at the end of the sessions as well? Yeah?
Yeah, I'll stay at the end of the meetup if anyone wants to hear about the projects, the technology that we're using, and the type of code that we are recording. I'm part of talent acquisition.
Wonderful, thank you. So Kevin will be around, and without his help, especially with the sign-up and the organization process, this would not be possible. So thank you very much, Kevin. Then there's Greg Pearl from InWorld and Troy at the back here, who are responsible for recording our presentations here. And we will upload presentations as we go to our YouTube site, Data Science Sydney. Just Google it on YouTube. And last but not least, Eugene Dubozarski with his company Prescient.com. He sends his regards. He is in New Zealand today, teaching his data science courses. And if you're interested in learning more about data sciences, check out his website, Prescient.com, for his current offerings. So, with that, there's two housekeeping items. The standard structure here is that we have two talks, each about 30 minutes, including 5 minutes for questions. After both talks, we'll open the floor to announcements, so if anyone has jobs or interesting projects to announce, and that's the time for that. And after, when we hit roughly 8 p.m., we still have about half an hour here to mingle, network, and get to know each other a little bit better over drinks as well. And the last housekeeping item is this thing. Please remember to leave your badges in the box downstairs as you exit. There will be, well, it's that high and has one roughly card-sized hole in the middle. That's just so we know that you exited the building, and that's why we need to have these somewhat complicated sign-in procedures as well. So please leave the badges on your way out. Thank you very much. That's enough for me, I think, and I would like to introduce our first speaker for tonight. It's HERVE COMMEIGNES. He started out as a software engineer in the financial sector, but now works at Fairfax Media as a data scientist in the product team. His role there is to improve the product and increase revenue through using data well. And he's worked with recommender system for product improvement, as well as classification models for customer churn. Please join me in welcoming HERVE on stage.
Thank you.
Today we'll talk about data science for business, the art of making money. Thanks so much for being here, HERVE.
Thank you, Fabian. Can you hear me okay? Excellent. Okay. Let's start up the laptop. Hello. There you go. Get this presentation going. All right. And here we go. All good so far. Okay. So I work at Fairfax. It's a media company, and we do things like we publish the Sunday Morning Herald or the Financial Review. So we do lots of good news, basically. And I'm part of an unusual team, a small team of 2 data scientists. I'm one of them. And as part of that, we need to basically do everything from the whole life cycle of what you can imagine as data science, from figure out which project to work on, work with the various people in the business to see if they make sense, get some data, do modeling, prepare for production, do production support, and at the end, evaluate whether we've achieved the initial objective. So it's quite an unusual experience in a way, because you get to do a lot of things. And it's kind of that experience that inspired me to give this talk. Now the title is a bit cheeky, but what I'm really trying to say is what we want to do is try to maximize revenue for our employer as a data scientist. And I'm going to give you some strategy to do that, or some ways to do that. Something that I've seen work reasonably well at Fairfax. So let's start with a bit of background, I guess. I presume many of you may have seen this slide already. It's quite a classic slide. It basically says data science has 3 core skills: programming, mathematics and statistics, and business or knowledge business domain. And you'll notice its intersection is called unicorn. And it kind of means that it's a bit hard to find people with these 3 skills that are actually good at all 3. And they're quite valuable. What I've also noticed, because I actually switched to data science a few years ago for doing a lot of online training. And I've noticed a lot of the training is actually up here, around math, stats, and machine learning. There's not a lot of training here. And the same thing you'll see with a talk like this ones. You have a lot of people who talk a lot about the neural networks and random forest and the techniques you can use. This is a bit harder to approach. And one of the reasons is because it's very industry specific and very domain specific. So it's not so easy to talk in a way that as applicable as if you were talking about deep learning, for example. So this talk today is going to be a bit more abstract. I'm going to use a lot of examples. I'm going to use analogies. I'll try to make it still interesting and fun. And because it's going to be abstract, I hope that the best ideas you're going to get out of this talk will come from your own minds. Meaning, think about how it applies to your situation and how you can use it. How it might trigger some ideas about how it applies to you. Essentially, the purpose of this talk is to help you look at things from this side of the circle, if you want. And if you can do this too, you can do this one too, as long as you kind of keen to do it, I guess, or motivated to learn. But it's not that difficult. It just takes a bit of a methodology, like everything. All right, next. We lost you there. We lost our slides. There we go. Okay. All right, so don't worry if the slide is a bit confusing. I'll walk you through it. Literally, I'll walk you through it. Just focus on the top bit, revenue-driven data science. So the whole point of this is to use revenue opportunities to drive what project we're going to be working on, okay? And it's kind of, I guess, aligned with the whole gist of the talk, which is how do we make money? So given the top line here, how do we do it? What are possible ways to do it? I'm going to start with on this side of the fence here with the senior management. And senior management, they tend to know fairly well in any kind of profitable company. They tend to know fairly well the products, the customers, and the competition, and also industry trends. And they would have some ideas about what are the key things the company or people can do in a company to increase revenues. So I'll try to give you a few examples. For example, the company may have in its main product line a new competitor that came in, and that's eroding their market share because they came up with a better product. And that better product is a lot easier to use, and they suspect that the new startup is using machine learning to actually achieve that. So here's an example of a target where the senior management say, hey, we're losing our main source of revenue. We need to do something here. Another example could be that the company has a new product line, and because they are quite innovative, they have no competition, so they have a high profit margin on that particular new product. However, the take-up of that new product is a bit low. So they're pondering, how can I get our existing customer to get interested in that product? What are the cross-selling opportunities? Which of our existing customer could be more relevant to that? That's another example of a target. Third one could be that senior management or the industry trend identifies that the cost of acquiring customers for a particular product is higher than industry trends, higher than our industry average. And it must be a way so that we can reduce that cost to be more competitive. So here are the examples of real targets that will lead to tangible revenues. Now, how many of you guys are in this part of the fence here, the data science? We work with data science in industry. A few? Okay. Now, among you, how many know at least one of those targets? 1, 2, 3. Okay, a few. And actually, I forgot to. I'll backtrack a bit. Imagine that this is a field, right? I'm going to use an analogy to make it a bit more memorable, interesting. This is a field where the company operates, right? So green grass everywhere. And we have a senior management holding the targets. And we have a data science team with lots of fancy tools. And by the way, this is a very poorly drawn cannon. Okay? Didn't have time to fix it up. I'm not that good. But you can imagine that as data scientists, we have various tools we can use to hit a target. But if we don't know the target, it's a little bit, you can imagine that there's a massive fog in that field. And data scientists on this side cannot really see the target on the other side. It's the same as you cannot see the slide anymore. Such a short time span there. But this is a bit what's happening. So if we can see the target, we might hit it by chance, but it will only be by chance, really. So how can we see the target? There's a couple of ways, and then nothing is easy in that sense. It depends very much on the organization you're working for as well. But as a general rule, basically walk up the management chain. Ask your boss, and don't take no for an answer. So if somebody says, I don't know, say, who else might know? Or who might be aware of things like that? Sometimes you might get some really good clues from people called analysts, or from these people, sales and marketing, who would have some target already set for themselves. But you can find that information, but it's probably going to take a bit of digging. Okay? So that's kind of step one is try to identify projects with high revenue potential. And when we have a project in data science, what we try to do is get an order of magnitude. Right? Is it a $100,000 revenue project? Is it $1 million revenue project? Is it a $10 million revenue project? So we don't know for sure. There's a lot of uncertainty. But we want to have an order of magnitude. Second thing that's really important is to keep in mind these people here, the specialists. They're the one who know how to do things, basically. How to sell, how to find customers, how to build a product, how to reduce fraud. And they're the one who turn our models into tangible business value. Because we tend to forget that what we build is kind of an intermediary product. So it may be a fantastic model, super efficient, but somebody has to go on the other side of it and transform it into revenue. And these are the people. And it's very important to understand their perspective and their needs. So it's very easy for us to work on this side and assume we know a bit more than we really do. And to make assumptions, basically. We say, okay, it's pretty obvious what they need, I'll just build it for them. So if we were working, say, on an attrition model, a customer churn system, we might want to say, okay, we'll just build a classifier that classifies very accurately the people likely to cancel on a product, for example, or to leave us as a customer. And we could do that. We could be very proud of ourselves. We've got a 95% model. And we go and proudly build it and present it to marketing. And marketing looks at us and say, well, what do I do with that? Because if I don't know why somebody is leaving, I can't really have a target message for them that will work for them. So what I really need is not perhaps a super precise model, but I need a list of perhaps 5 classifications, potential reasons why somebody might leave. And with these classifications, then I can actually target a message or design a strategy to keep them. So that's the type of thinking that helps a bit to transform a successful model into revenue, effectively. And of course, tool selection is something you guys can do well. But it comes after that I guess that exercise of figure out how big the problem is it worth spending much time on it, and how will it work with the workflow of these people? Can they use it at the end? So ideally, we want to drive it this way. And often, what I've noticed is it's driven the other way. We do a lot of projects that are capability driven. Let's build it before we can, or it makes sense, or it's new fancy technology that's really interesting. And when we build it this way, there's kind of 2 problems. First is there's so many choices. So which one do you pick? Just move your mouse. And the second one, and so it can be quite overwhelming, and we may do a lot of prototypes on this stage, but then how do we decide? This is why we need to go back to some idea of the potential, so we can actually help prioritize them. So that's pretty much I guess the analogy of the field. There's 2 ways to go about it. This is far easier for us because we know this very well, and we know what's feasible, and we tend to do that very naturally. This is looks like a lot more work because we need to figure out a world that we will not be so familiar with, but it's more likely to lead to the eventual result. Let's go next slide. Thank you. All right. So to help you, for those who don't have much visibility on revenue and things like that in your company, these are 4 classic ways you can make money on with data science. They're quite well known, so I'm not going to go through them in too detail, but customer churns are the classic ones. Help acquiring customer, prevent losing customer. Oh, by the way, I'm going to post the slides after the presentation, so don't be too concerned about taking notes. The second one is quite interesting. Is people don't think much about it, but it's improving the customer experience of the product. So, for example, you got a loan application. And 5 or 10 years ago, these loan applications were a real pain, really tedious, like 5-10 pages of entering every possible detail. And a lot of people didn't complete them because it's really, really annoying. And now we have more nimble players who come in the market, and they use everything they know about you to make that process super easy. And they use everything they know about the type of person you are and the segment you are. And that makes that process so much easier than this more nimble competitors are actually doing quite well. And this helps in us. And a lot of business have amazing possibilities here to improve the product by using what we know about the customer to make our product better. Reducing cost, an obvious one. These are borderline things. So sometimes you might have a classifier that can automate some tasks, but they're rarely perfect. So I guess a practical way to go about it is to say, well, the 80% we're sure about, they'll be automated. The rest will go to decision support. Escalate to a particular person. Fraud detection is the other really classical one that has had a lot of success in protecting revenue rather than increasing revenue. The other important thing is building that relationship with those specialists in the middle. Okay, it's easy to think we know the world better than we really do, and really what we want to do is to be able to see the world from their point of view. So if you talk to marketing and you never heard of the concept of a segment, you're not going to have a very fruitful conversation, for example. So you need to understand a little bit about what the main terms and concepts and areas of interest are. And you also want to ask them interesting questions to try to draw what could be useful, how you can add value. So things like what are their pain points? What makes doing the job really difficult? They could probably do a much better job if they had better information, better system, whatever. What would that be? So it's not just about saying, oh, I've got this great model for you, let's build it. It's more about, okay, what would we provide you the most value to help you do your job? And talk about it openly and ask. It might be some really interesting things, like the pain points are a classic one. Everyone is one information you lack. They may tell you, well, if only I knew the income of my potential targets, I wouldn't waste my time on the one who can't afford it. And that can give us an idea of, well, okay, with all the data we have, what can we do to estimate people's income? There might be a way. And that model that you wouldn't have thought of building otherwise can actually be a big win for the marketing team. So there's a lot of exploration going on, a lot of relationship building going on as well. You really want these people on your side, be happy to work with you and tell you, in a way, all their secrets, or tell you really how they work and how they're struggling in what they do. Because in the end, it's a partnership. What we produce, they use to produce the end benefit. Got another little diagram for next. This is really about measurement, and measurement is a really interesting concept because the biggest trap is to focus on what's easy to measure, not what's important to measure. And you see that a lot. There's a measure that's easy to get, so we'll use that measure, and we are satisfied with that. And for us, it's easy to focus on the accuracy of a classifier. We say, okay, we'll build a classifier. 99% accuracy, 95% accuracy, fantastic job, done. Fantastic. But that's not really the way I guess the rest of the company sees it. They actually evaluate our work through one of these things, like the actual business outcome. So there's a lot of variability here, so I can't give you all the options. But three classic one is the model becomes part of the product, so embedded into the product, make a better product. Another one would be some kind of decision support. I help find customers, help acquire customers, prevent losing customers. The third one is some kind of basically PowerPoint presentation. And you advise management, and you tell them, okay, we believe we should do this. And each of these particular outcome would have as its own way it can be measured. Okay, the simplest one to measure in dollar term is this one. You can measure the dollar impact of the number of customers you've kept, number of customers you acquired, and things like that. For a product, there's also ways to measure the impact. You can figure out if you, like some product implement, what it would be the conversion rate, for example, for a product application, how quickly people complete certain tasks, and whether this product is much easier to use than the previous one. And for this one, it's as simple as asking the person you presented to 2 weeks later whether they implemented the recommendations or whether they had the chance to think about it and perhaps to use it. And you might find out that they didn't, which is a bit disappointing. And in that case, we want to know why they didn't. Is it because we made recommendations that were just too expensive to implement, or they were too risky, or we forget to take into account some aspect of the organization that make it not possible to do? And we'd like to know this because hopefully the next time we present to this group, we won't be making the same mistake. At least we'll get a bit more knowledgeable as to what makes a recommendation that can be used and actioned. So what this is all about is really to think about not this measure, not the classifier accuracy, but this measure here. That's a big question mark. And in many scenarios, it's not even measured. We don't know. We're just like, oh, we've done our job. It's up to the sales guys to do their job now. But really, the executives, if you want to watch all this, they actually measure the impact here. That's the way they perceive the success or failure of the operation in a way. And that can take a bit of effort to measure, like especially if you had to put some special analytics. So, however, it's very important to measure because it gives you a sense that you've achieved the initial objective. And if you haven't, you have a chance to go back to the drawing board and see, how can I modify my model so I get better business outcome? Not better accuracy, but better business outcome. So this is it. This is what we try to optimize here. And we don't think about it, but that's what makes a difference as far as increasing revenue is concerned. All right, I'm gonna go back to this one, okay? I talked about capability-driven versus revenue-driven. I'm gonna give you a real example of how that turned out. Okay. So this is about a recommendation system to recommend news articles when you're reading online. So say you're reading an article in the Herald, for example, or in the Financial Review, and you really like this article, and you really like to perhaps read another article that's a follow-up story or very related. That keeps you engaged with the newspaper. And it's a good relationship because for the online media, it keeps the audience engaged, and for the user, they get more value out of what they're doing. So a few years ago, data science team they, identified this as something important to do and built a recommendation system using collaborative filtering. How many of you are familiar with collaborative filtering? Quite a few, but not all. I'll give you a very simple version of it. Okay. Think about a matrix, big matrix with all the rows being your users or your customers, and all the columns being the products they buy or consume or purchase. Okay? And there's massive matrix here. And if you look at the rows and see how similar they are, you can find basically people like you who have similar tests as you have. Okay? And from this cohort of people like you, we can find what they may have consumed that you haven't consumed. And that is effectively the basis for recommendations. So we find people like you and see what else they've liked or used and what you haven't used. So it's a fairly classic solution, and at the time it was built, it was actually the obvious choice in a way. And the impact on revenue was actually never assessed or estimated. And you had, adoption was fairly good initially. There was a lot of enthusiasm around it. We were very excited. It was the first recommendation system. But then the business lost interest in it because there just wasn't, they didn't see a lot of value in it. They didn't quite understand what it was for, as far as they were concerned. Okay, a few years down the track, same problem arose, but this time we start working with the editors, which are like the core engine of the, effectively, the media organization. And that comes back as a business pain point, that we don't have a follow-up story. And the key issue is that many of our customers, we don't have actually a full history of what they do because they may have come just on their first visit. So we come up with a simpler solution, which is called association rules. And effectively what this means is conditional probability. So given I'm looking at this article, what other article am I much more likely to be interested in, even if I've only seen this one. So super simple. And yet, it actually worked quite well. We did an A/B test and estimated the potential revenue. And this one is currently widely in use. And the business knows why it's there, and they can see the value. So that gives you an idea of two different approaches. This one is actually more complex and more sophisticated. But the business didn't see the value. That's a bit of an issue. All right. That's pretty much it. I'm going to leave you with two thoughts, I guess. One is be aware of the potential of any kind of project you're engaged in. You need to understand how your company makes money and how, whether a project or an idea is a 10 grand idea or $10 million idea. The second thing is to really work well with these people in the middle. There's not all of them, but for every project there's at least one of them involved. And that will be the key to actually make it work for you. And it'll also be the key to uncover value you may not have initially foreseen. So if you work with them and really understand what they need to do their job better, you can come up with lots of ideas about what to build that actually will generate revenue for the company. All right, I think I've been long enough, I'm told. So thank you for your attention, and let's take some questions.
Thank you very much, Hervé. Are there any questions?
There's one hidden there.
Far end, wonderful. We'll pass around a couple of microphones. I'll go that way.
Thank you for your presentation. I have a bit controversial question.
Sure.
Do you believe that any company should start with infrastructure collecting data, or rather they should start with modeling and trying to understand what exactly they need? Thank you.
It's so difficult to answer generically, you know. This is one of the hard business decisions because typically the phase one is to collect analytics so you can see what's going on. Otherwise, it's going to be hard to even identify with data, you know, what are the possibilities. But on the other hand, you don't want to spend $10 million on the analytics stage without starting to look into where are the revenue opportunities. So it's a trade-off. Just collect enough analytics so to at least try to figure out where you should focus on, and then dig a bit further into it. But but it's such a company specific, I guess, issue that I can't be much more precise than that.
Further questions? Yeah, you got one? Wonderful.
Thanks for your
Hello.
presentation. So with the capability driven and the revenue driven
Yeah.
table, is it also maybe just a stage of the client relationship, that it could be the first point you're showing them how you can address their needs, and at the second part you're kind of, now that they've seen that you're able to address their needs, that you can kind of sell them more capability to do things?
Yeah, that's a really good point, actually, because as part of all this, I didn't quite cover it because I can't cover everything, but a key point is to build trust. Really build trust with these specialists and operational people that will really be key to make it happen. And for that, what helps is to have a quick win on the board. Okay, nothing big. So you don't want certainly not a one-year project or anything like that. I'll get them impatient and wondering what's going on. But something you can build super simple that helps them. Something like within a few months. And these are usually identified by talking with these people and figure out something simple you could do to help them. Once you develop that relationship, once they know you can be useful, then you can, I guess, start on a bigger project, on a bigger discussions as to how do we really make it better. And then you'll have more likely more funding to do what you really want to do, and also more time. So you need big wins, you need to build trust. Because at the beginning, the specialists wondering who are those wizards who are data scientists and what can they do for me? And they're not that convinced. They don't, they don't come always thinking that it's gonna be fantastic. So build that trust.
Thanks for the presentation. Actually, like you mentioned about the fraud detection, I would like to check with you whether is there any tools or techniques involved in fraud detection? Because I know there is a method like a Benford's law, so I'm not sure whether is there any other techniques apart from that.
I don't know. It's a very simple answer. Probably the best answer to give.
So we always use the Benford's law, which is working, but I'm not sure whether there is any other techniques which we can use it for to detect a fraud.
Yeah, I can't really help you there. I haven't actually done fraud detection in his current job.
Anyone else?
Oh, there's a few coming up.
Thanks. Always good to be reminded of the basics, right? Who was the hardest person that you had to convince to come around to your way of thinking? And how did you do it?
It was the product people. To build a recommender system, we had to integrate into a product. And the product people, they have people coming from all over the shop to say, hey, build this into the product because I believe in it. And it was not easy to actually get the ear initially because they had a perception of anything coming out of data science taking years or at least months and being complicated and risky. So this is why we actually came up with a fairly simple concept to say, okay, look, we can build this, and here's a prototype, and you can see it working. You can see the results live. So this is in that particular company. In other company, you might have to be concerned about like the finance people or the management people who say, okay, show me a strong business case, and this could be a different story. But in my case, it was the product people.
Thank you. We've got a question here.
Thanks very much, Arvin. I have a question around business governance. Just wonder, it sounds like you do have some input in terms of, if you're able to obviously go in and talk to the various stakeholders and obviously gather information in terms of what their objectives are and how that serve the overall business objective. And then you'd be able to formulate your the data question. My question is, how would you be able to, I guess, get in a position where you get that? Well, basically, I guess from day one when you hire, were you basically given a blank slate and say, hey, increase our revenue by?
No, not really. No, not really. I guess yeah. I think there's a lot of aspect to that, right? I mean, it's my nature to take a lot of initiative and go out of my job definition. So no, I was not given that particular slate. However, we had the data science team that didn't have a clear direction of where the big project was going to be or the revenue was going to come from. So any kind of the advantage we are as data scientists is we know what's possible better than anybody else. So if we can marry that with revenue opportunities, then the two will work. And this is essentially what I've tried to do. So as I started to, the approach I took started to resonate with management because I wasn't talking to them about neural networks or epsilon or gamma. I was just talking to them about dollars, and they understood exactly what that meant. And once you get their attention, then you get their backing, and you say, okay, go and talk to this person and see how we can make that work. So it's a very progressive, I'd say, endeavor, and it's probably easier, to be fair, probably easier to do in a smaller company than in the very large company where things are very regimented.
Two quick ones, maybe? Yeah.
So strategically, like, Sydney Morning Herald work on a subscription-based model, sign up new customers,
Yep.
$30 a month, right?
Yep.
How do you, or how does the company say, okay, in 5 years' time, it's going to be on a per transaction basis or on a per time basis, that it's 0.001 of a cent every time they, how do you then meet the longer term visions of, yes, we should be working on something strategically down the track, as opposed to delivering something that will give us $1 million in 6 months?
That's a super tough question, especially the media business. If you're not familiar, it's going through a lot of disruption, and the business model is being transformed. So Fairfax is trying to find a new business model effectively. And the way the industry changes right now around the media is nobody can tell what the industry will look like in 5 years anyway. So there's no point having a 5-year strategy to a certain degree. You have to be fairly tactical. And this is where the $1 million project per year are quite helpful, because it provides revenue to keep going. And they are fairly small experiments that are not betting the farm on some big new mega system or something like that. So in an industry that's highly at risk, can't afford to take big bets effectively. So it's almost by definition tactical more than strategic. One more? Hello?
So for those who are looking to hire their first data scientist, what should we be looking for?
You're talking about a company hiring their first data scientist?
Startup.
Startup?
Yeah, so I just wondering if there's something particularly different or unique about your first data scientist that would make all the difference.
Find a unicorn. That was the first slide. No, joking. It's it's real challenge, really, because you especially as a startup, you want to be very nimble, and you want to be able to react quickly to changes in your own marketplace and your own strategy and things like that. So I would probably go for somebody who doesn't have to be the most experienced data scientist, but they have to be somebody who's willing to learn and change direction and try new things quickly. You don't want the super experienced scientist who has one way to do it, and because it's worked for them well in the past, and they may not be willing to I guess, explore many newer stuff, because the technology we're using changes amazingly quickly. Like from deep learning, many people didn't see it coming 5 years ago. So the most important is somebody energetic, willing to learn and experiment, which means somebody young. That will probably be my best bet there.
Well, please join me in thanking HERVE for a Great presentation. Thank you so much.
Welcome.
It's been a pleasure to have you here.